One problem. I'm cool about growing in the cold. The cold will take up your whole team. So I might pull it again because I might not even.
Oh, they canceled our practice today because our heater broke.
Oh no, that's
So they said the pool was like 70.
No, so nobody used the black.
70? It should be lower.
Perks are black.
No, because the pool at UNF is like 70.
No.
No.
You cannot get in like water that's below 76.
Wait, you guys are swimming?
Really?
No.
I got mine canceled.
Pretty sure ours is at 76 or 70. Like
I know it's
75.
been
Yours is
a while.
at
I think you-
but
80. Yours is
last
at
time
80.
we talked about. I'm sorry, what?
I think it's like 70, 78 maybe.
I apologize. You know what?
Maybe.
Both of my 1A and my 2A classes did not ask me about my dad jokes. All right. What do you call a lizard in an outhouse?
A gizzard.
Camo. What?
What do you call a lizard in an outhouse?
Iguana.
Campylene?
Wait. A reptile. A slither.
A Komodo dragon.
Oh.
I got the camo.
A Komodo dragon. Commode? Bathroom? Commode in the bathroom?
I know that.
Commode bathroom?
Dude, the way I was like,
Commode bathroom. I didn't know that was a word.
That's why I get it.
I had no chance.
We're in the same position.
Our zoo
I had no
has
chance.
some.
Survive.
Yep. In the Asia section.
Let's go about Tony.
Super fun, yes.
Merry Christmas.
How was my
I believe
Christmas?
you're gonna win.
It was good. After Christmas on the 28th, we took a trip up to Nashville to see some
Right after the
family.
game,
We didn't see snow though, so.
Is it away or here?
Yeah.
Buy each other lunch. I don't
So, yeah. If it's so, it has been the last time it snowed here,
30
like for
years?
real, was 1989.
Dang, that was doing a
Not
nice time
close,
to
like-
be alive.
Yeah, there was a handful of years ago, maybe 7 or 8 years ago. I think there was some flurries seen over here on the west side.
There was frost.
Well, I mean, there's frost any particular morning, but yeah. So I do remember there was some flurries seen somewhere, but in 1989 it was like for real. Like the city shut down. People were sledding down the Dames Point Bridge.
Sick.
It was, yeah. I was 12.
I'd be terrified to sled down the Dames Point.
Wait, but like iconic Jackson How do you snow down? I watched Red Light Play. I'm thinking about like, wait, what do you mean like?
You know where the Dames Point is? They were sledding down it because the roads were closed because the city shut down from the snow.
Somebody definitely died.
Probably. Have you seen that?
I was in Georgia the last time I saw snow.
Back in 1989.
No, it's
I like your hair.
People were sliding
Oh yeah,
off.
yeah. I spent fourth and 10th grade.
Dang,
of my
man. First day of
childhood
school back? You're not going to send a chair first day back?
I'm not gonna cover his Hey, don't use it.
All right, guys. Let's talk about me. Let's get into physics.
Wait, I missed the talk about you. Yes.
You can catch up later. All right, so you will see. Okay, never mind.
Mechanical pencil, please.
So at your desks, we have a spring and we have some masses. And we've kind of talked about that before. We are going to find the spring constant of the spring, but you've already kind of done that. But we're going to use this easy lab to kind of showcase how do we deal with uncertainty when we have to graph. Okay, so remember way back ago when we talked about uncertainties, it might have been a couple months ago, but we learned how to find the uncertainties, first of all, when we're taking data. When we have a screen, like the scales back there have a screen, it tells you the grams of whatever object you have on there. And remember, that the uncertainty, or our plus or minus, was equal to half of the smallest place value that it is. Not half of the last digit, but half of the last place value. So if it goes down to the 10th of a gram, okay, and let's say that I have something that measures 10.0 grams, that means that my plus or minus, my uncertainty, is half of the last place value. Not necessarily half of, let's say, if this was like 0.3, not half of 0.3, but rather half of 0.1, because that's going to be the place value. So half of 0.1 is going to be 0.05. That's going to be consistent across the board when you do the scale mass measurements. Now, we will also be measuring as part of your lab, and your instructions are in focus as always. So you're going to have to measure the length of your spring using a ruler. And we know if we use an analog device, our eyesight plays a key role in terms of how big the uncertainty is. As in, can we tell if it's on this line or this line? Or can we tell more specifically if it's on this line or halfway between the two lines that come after it, okay? So based on how precisely you can measure, which will change based on whoever in your lab group does it, that may change slightly the uncertainty of the length measurement. So you're going to measure the length of the spring with no mass on it. Then you're going to put some mass on it, enough that you can tell that it's stretched at least a little bit. And then you're going to measure that stretched length, okay? And of course, Hooke's law, if you remember, the force is equal to our spring constant times our displacement. That displacement is how much it was stretched. Not the original, not the new stretched length, but how much did it stretch, so the displacement. So we're going to have to subtract the new stretched length from the original unstretched length. But remember, how will we carry through the uncertainty? If we add or subtract things, we have to add together the absolute uncertainties. So let's say that that I have a plus or minus 0.1 for each of these. Okay, I've got a plus or minus 0.1 for my unstretched length. I've got a plus or minus 0.1 for my newly stretched length. So when I find my displacement, I have to add those plus ones together to give me a plus 2. So my displacement, that's really what we're going to graph here, is going to have a plus or minus 0.2. Because as we do things with data that have uncertainties, the uncertainties compound, they get bigger. Okay, now, the typical lab portion of this is simple, okay? We need 10 points. We're gonna put 10 different masses on the spring to make it stretch an amount that we can measure. Typically, we're gonna start, I would say, start with 200 grams because these are particularly sturdy springs, and then we're gonna increase by 100 grams each time, okay? So 10 points, we're going to collect our masses and our displacement data, and we're going to graph the mass on the y-axis and the displacement on the x. And it should look like a line. We don't have to manipulate our data to make it look like a line. It should be a line because Hooke's law, there's no powers, there's no roots. It's the force to the first power and x to the first power as well. Okay, now, technically the force that is acting on the spring is really the force of gravity, or the weight of the mass, but we're just going to kind of ignore the g just to make things as simple as possible for today, because again, the spring constant is, although it is the end result, it is not the main goal for today. The main goal is practicing uncertainties while we graph. So we're just going to graph the mass versus the displacement. We're going to get a nice line. We're going to do a line of best fit. If you're hand drawing it, of course, we're going to make sure that it is a nice average of our points, okay? Of course, if you want to graph on Excel, you are more than welcome to do so. In fact, I would encourage you to graph on Excel, especially since we have to add uncertainty bars. So after we graph it, we have our nice line of best fit, we find our slope. I might have said before, but IB calls the slope the gradient. So you may find that occasionally, especially in your books as well. Slope or the gradient, it's the same thing. But your slope or your gradient is going to be equal to your spring constant. Okay, so that's what we're trying to find. Now, once we graph it, these points, now we have to consider, okay, well, we've got uncertainty. These points aren't exact, okay, because they have ranges of uncertainty here. We're not exactly sure if it's exactly that point because we have uncertainty. So I'm gonna zoom in here. So here's a point. So basically, what we're going to do is we're going to draw little TIE fighters here, okay, with the uncertainty. So notice that my mass, I plot on the y-axis, and that's going to have an uncertainty of 0.05, okay? Now, if I were to be hand drawing this graph, I would have to use my ruler and measure out exactly 0.05 from the point. 0.05 up and 0.05 down. But Excel, it does it for us. So Excel does, it's going to save a whole lot of time. Now notice that my displacement, assuming that my scales are the same, which they're not going to be, but let's just assume for this picture they are. Notice that my uncertainty, my plus or minus for my x values are 0.2. That's 4 times as big as 0.05. So I'm going to make my x error bars, again, measuring it out. So this would be plus 0.2, this would be minus 0.2. This is plus 0.05, minus 0.05. Okay, so each one of my points here is going to look like a little TIE fighter. Okay, and you can do it for all of them. I'm not going to, but there you go. You get the idea. Now, again, the whole uncertainty aspect means that we don't actually know where the real point of data is, but rather it is somewhere within this box of possibility. The real data is somewhere in here, okay? So, once we draw our error bars on the points on our graph, the next thing is, okay, well, the whole point of this was we found the slope, or the gradient of the graph. It also needs uncertainty. So how do we do it? So we have to basically find what is the minimum slope possible and what is the maximum slope possible. Here's how we do it. So I'm going to look at my graph, and your graph may be very linear or not very much, but we're going to find 2 points that are as far away from each other as possible. So first and last, if they work, then that's fine. But they also should be close to the line that is drawn. Okay? So choosing from the first 3 or the last 3 points, choose one of those that is the closest to that line, if not on the line itself. That would be ideal, but not required. Okay, so we're going to choose our first and our last points because according to my data, those fit the bill. They are far away from each other and they're close to our line. I do not want to choose 2 points that are in the middle and right next to each other. I want them as far away from each other as possible and close to the line as possible. So what we're going to do here is we are going to find the extreme corners. So if I'm trying to find what is the maximum slope here, so if this is the real slope, the maximum slope will kind of look like that, with a steeper slope, a steeper gradient. So we're going to find, okay, well, I calculate my maximum slope by finding the extreme corner, the top left-hand corner of this piece of data. And I'm going to find the bottom right-hand corner of that piece of data. Okay, as we look at what that means on my zoomed in portion, here's my top left here's my bottom right. So taking my 2 points, like my first and my last point here, I'm going to find this one, I'm going to minus 0.2 for my x. And I'm going to add 0.05 on the y. And that's going to be that point. To find this point, that's going to be right here. So I'm going to add 0.2 on my x. And I'm going to subtract 0.05 on my y to find that point. And then using those 2 points, calculate your slope. If you were to draw it, it would look like that. And this would give us our maximum slope. Okay, so we do the same thing, just with the opposite corners to find the minimum slope. So I'm going to use the bottom right-hand corner of this point, and the top left-hand corner of that point. Do that same thing, find the slope, and that's going to be our minimum slope. Last but not least, we have to find what is the difference between the max and the original, find the difference between the minimum and the original, average the two together, and that's our uncertainty. For example, let's say that we had a slope of, let's see, 50 units, okay? And then my maximum slope, it was 54, okay? And the minimum slope I calculated was 51, okay? So now I need to find the difference. The difference between these two was 4. The difference between these two was only 1. So then I average the two and I get 2.5. So my final answer. So the lab is asking to find what is the spring constant, or what is the slope, what is the gradient of this graph. So my slope is going to be equal to 50 because that was the original slope that we calculated based on my line of best fit, plus or minus 2.5 and units. All right, so that's how we're going to carry through the uncertainty into a slope calculation. So let's review one more time, okay? First, we're going to do our basic lab stuff, okay? As we record our data, I'm going to write down my uncertainties for both my mass and my lengths. I'm going to carry through the uncertainties as I calculate my displacement based on the stretched length minus the original length. I'm going to add together my absolute uncertainties so that that should be bigger than what it was before. I'm going to graph it, draw my line of best fit, find my slope. Then I'm going to add my error bars. I'm going to tell Excel, and I will, around the halfway point, I will showcase how to add Excel's error bars for you, okay? If you get to that point before I show you, just ask me and I'll do it earlier, okay? So add in our bars of error, and then we're going to look at our graph. We're going to identify the 2 points that we're going to use far apart from each other and close to our line, and we're going to find our extreme corners. Using those extreme corners, we're going to find our maximum slope and the minimum slope, and then we're going to find the differences thereof, average those two together, and that's going to be our plus or minus of our answer, or the uncertainty of the slope of gradient. Okay? Any questions? Jordan?
You said our starting rate should be 200.
Yes.
Okay. Is there a 50?
So
it?
I'd say at least 200. You don't have to do exactly 200, but there are 50s. If you really want a 50, then I can find one for you.
Thank you.
Yeah. Okay. So any other questions? Let's keep it the typical 2s or 3s. So feel free. My groups of 4s, you can split up. Kayla, you're going to have to join another group as well to help out as well. All right, but only one graph. Also, please keep in mind that you don't actually have to draw your min and maximum slopes. That was just to kind of show you the process, what we're actually finding. So you do have to calculate your minimum and maximum slopes, but you don't have to show them on the graph. At least not right now. But that will be easy, and we can talk about that later. Okay? All right, so at each table, you should all already have a set of masses in your springs. If it helps, if you're vertically challenged and you need the rod lowered, you can just loosen it and lower it yourself. That is completely fine. Also, these masses are heavy, so don't make them oscillate, because if they bounce, there's a good chance they will fall off and they can break some toes. Okay? I kicked a stool last night and I might have broken one of my toes because it still hurts. But they don't really do anything for broken toes. You just gotta let it heal. So, unless it's a compound fracture. And I know it's not, so. But yeah, it still hurts. But it hurts less now than it did last night, so that's good.
Maybe.
But yeah, don't break your toes.
I won't.
It hurts. All right. So again, maximum 3 per group, and let me know if I can be of more assistance. I had a good number of groups in my 2A class finish today and get that extra point for doing so. If not, it is officially due at the end of class on Thursday. So we will start off with our regular lessons again on Thursday. All right, let's get started.
No? 2 to 3 now.